All right, so we're going to start taking a look at adding some simple fractions here. So we'll start with just some manipulatives to kind of see how it works and kind of go over a couple of common misconceptions we have when we add or when we subtract fractions. So let's say, for example, we wanted to add together 1/6 plus 1/6. Okay. All right. So a common misconception is to simply add the numerators 1 plus 1 and add the denominator 6 plus 6 and get that equal to 2/12. Okay. But if we look at the idea of 2/12 and what that really looks like, okay, we can quickly see that that's not the case, right? 1/6 in fact is equal to 2/12. So if I add a 6 and a 6 together, right, we're not going to get to 2/12. So we don't just add the numerators, add the denominators, all right? And if we see here, if I want to add a 6 and a 6 together, right, just like it shows, well, it's just 2/6. Okay, so we're just adding the numerators together. The denominator just tells us the size of the piece. Okay, we've got a 6th and a 6th. If I put two of those together, I have 2/6. Just like if I have an apple and an apple, I put those together, I have 2 apples. So the denominator isn't a quantity. It tells us the size of the piece, how many pieces make up a whole, right? The numerator is the quantity. 1 piece plus 1 piece is 2 pieces. What size are those pieces? Those are 6. So when we have fractions that already have common denominators, like our example here, it's easy to add them together. We just add our numerators. Okay. Now, what happens then when we have two different size pieces? So let's say, for example, we wanted to add together 2/3. Okay. So we've got 2/3 there, and I want to add that together with 1/4. Okay. Well, we've got 3 pieces, but we can't say 3 because 3 what, right? They're different sizes, they're different pieces, so we can't say we have 3 pieces because we can't name those pieces because they're different sizes. So what we need to be able to do when we add is get them to be the same size piece. Okay, so in this particular case, and we'll go over this mathematically after I show you, okay, our same size pieces are going to be 12ths. Now, 12 happens to be the least common multiple of thirds and fourths, right? The least common multiple. If we think of the multiples of 3, 6, 9, 12, multiples of 4, 8, 12. 12 is the smallest one that they have in common. So if I put all those together and we look at, in this case, what that works out to, just about have them all here. So we can see that each third is represented by 4/12. So 2/3 would be 8/12. Okay, and then a fourth is represented by 3/12. So now they're the same size pieces. Now I can add them together. Now I can count my pieces. So I've got 4, 8, 11 pieces. Okay, and my pieces are 12ths. Okay, so if I add those together, 2/3 plus 1/4, I get 11/12. So let's look at how we can do that mathematically. So let's take the problem that we just did. We had 2/3 plus we were adding a fourth. Pen here, 2/3 plus 1/4. Okay, again, I will restate this. We do not, this is a very common mistake early on when starting to add fractions. We do not add the numerators, add the denominators, and get 3/7. Okay, we have to have the pieces the same size. So, thirds and fourths, right? Again, we talked about the idea that least common multiple or the least common denominator, right? If I think of the multiples of 3, like I said before, 3, 6, 9, 12, and so on. Multiples of 4, 4, 8, 12, and so on. We can see that the smallest one they have in common is 12. Okay, so we're going to use that as our least common denominator, right? So which means what I want to do is I want to take these fractions and I want to change them into 12ths. So let's talk about how to do that. Okay, So basically what I want to do is I want to look at what do I do mathematically with 3 to get to 12. Okay, and we're thinking multiplication or division here. Typically multiplication, but sometimes you might want run across one where you have to do some division. Okay, so what do I do with 3 to get 12? Well, 3 times 4 gets me 12. Okay, 2 times 4 gets me 8. Okay, and we saw in the pictures of the manipulatives, right, each third was 4/12, so 2/3 was going to be 8/12. Okay, what do I do with 4 to get 12? Well, I multiply by 3, so I want to do the same thing up here, right? And we saw that a fourth was equal to 3/12. Okay, so now my new problem becomes 8/12 plus 3/12, right? And I want to add those numerators. Okay, 8 plus 3 gets us 11. Okay, our common denominator is 12. Again, we don't add the denominators. Okay, just add the numerators. All right, let's try one more example. Okay, so let's say I had 7/8 and I wanted to subtract 1/6. Okay, again, the denominators are not the same. Now, sometimes students will just go, well, 8 times 6 is 48. Okay, and if you're stuck and you can't figure out the least common denominator, that always works. However, the bigger your numbers get, again, they just be a little bit more difficult to work with. So if you can find the least common one, the smallest one they have in common, it just usually makes the problem easier. There's nothing wrong with finding that, but finding the least common denominator is a skill that you'll have come up later when you progress into algebra and things like that. So practicing that skill now would be beneficial. So if I think about 8, again, I've got 8, 16, 24, and so on. Multiples of 6, 6, 12, 18, 24, right? So we see that least common one right there is 24, right? So we're going to change our fractions into 24ths. Again, what do I do with 8 to get 24? I multiply by 3. So I want to do the same thing here. So that becomes 21 24ths. What do I do with 6 to get 24? I multiply by 4. So that becomes 4 24ths. Okay, so my new problem now is 21 24ths minus 4 24ths, which gets us, again, we want to subtract the numerators. Right, I want to take the 21 and I want to subtract the 4. And that gives me 17 24ths. Okay, and always simplify if you can. This one we don't have to simplify, but it's just kind of good rule of thumb. Simplify your fractions when you're done. Okay, so addition and subtraction, we want common denominators. Once you figure out that common denominator, change your numerators, right? And then we add or we subtract our numerators and write our denominator. Denominator tells us the size of the pieces.